Hello all, welcome to our next video. We are continuing to solve a system of equations, but we're doing it now with a new method known as elimination. So we've done two methods already. We've done solving by graphing, we've done solving by substitution, and now we're going to describe the next one, which is solving by elimination. We use this method when both equations are written in standard form, which means y is not by itself. We write it like ax plus by equals c. That's part of your big ideas, so please make sure you get that written down, or what standard form is. Okay? Alright, so here's the steps that we take to solve a system of equations by elimination. We're going to have two sections over this. This is the first. The first thing we need to do is make sure we're lining up the equation. We put x's on top of each other, y's on top of each other, and our numbers on top of each other. This also includes our equal sign. From there, we're going to determine which variable to eliminate. You're looking at your variables that have the same coefficient. We don't care about positive versus negative, but we're looking that they have the same number. Step 3 is to solve. From there, we're going to solve for the variable that we chose. If it's same signs, you're going to subtract, and if it's different signs, you're going to add. Once you solve for that variable, you then plug it back into the other variable and solve for the second variable. So you're substituting back that value back into either of those two equations. Finally, we make it a point. It's super important that you recognize that solving a system creates a coordinate. We have x, comma, y. So you go through and solve for it. If it's different letters, it's alphabetical. Let's go ahead and take a look at an example. So step 1 is to line up your equation. As you can see, it's already done for you. X is on top of x's, y is on y's, numbers on numbers. So the next thing we do is determine the variable to eliminate. So with this, we're going to figure out, well, okay, I have myself two variables that have a y, that have a 5. So those are the ones that I'm going to focus on. And I like to box those up so that I focus on those are the things I'm looking at. So we want to get it so that those variables eliminate. You have to ask yourself, well, if I were to add those numbers, would they become 0? Or if I subtract those numbers, would they become 0? The thing with this is that if you add them, you're going to get 0. So I'm going to add this entire equation, which means everything else gets added. 5 plus negative 8x gives us a negative 3x. 20 plus negative 29 gives us a negative 9. So now I'm going to divide both sides by negative 3, and I get the value of x is equal to 3. So that's step 2. Step 3 now is to take that value and plug it back in. And it doesn't matter where. You can put it in the top one or the bottom one. Let's put it into the top one. So it's 5 times 3, because x is equal to 3, plus 5y is equal to 20. So kind of think back to what you did in substitution. Multiplying 5 times 3, we get 15. Then we're going to subtract the 15 from both sides, and you're left with 5y equals 5. So the y value is equal to 1. So we have two values. X is 3, y is 1. So the solution to the system, I guess I can't write that far, is 3, 1 as our equation, or as our point. So I'll write it over here. 3, 1 with the as a coordinate. I guess this goes off the graph. All right, let's take a look at the next one. So I have these guys here. They're already lined up. And now I'm going to focus in on here, because these are the ones that have the same coefficient of 1. So again, you're going to ask yourself, if I were to add these things, would it become 0? Well, if I add two negative 1s, I get negative 2. So the difference is now I'm going to subtract. So same signs, we subtract. Different signs like in the last one, we would add. So negative x minus negative x, they cancel out. Negative 5 minus 9y is a negative 14y. 2 minus 2 is 0. We can continue on since we still have a variable of y, and we're going to divide both sides by 14. 0 divided by anything is still 0. So now we're on to step 3 or 4. We're going to substitute it back in, and we're going to solve for the other variable. So I have negative x minus 5 times 0 is equal to 2. I could have put it into the second one if I wanted to. Get negative x plus 9 times 0 is equal to 2 as well. What happens is the negative 5 times 0 is just 0. So it's essentially not there. So I get negative x is equal to 2. So I'm going to divide both sides by negative 1. So the x value is negative 2. Remember, our coordinate is always alphabetical, so it's negative 2. Ooh, sorry. Negative 2, comma 0. So let's put it right here. Negative 2, comma 0 is our solution to this. Okay? All right, last example. Let me erase what I wrote on there just a second ago. So we want to go ahead and take care of this. Let me go back to my pen. All right, So in this case here, I could choose the x's or the y's to eliminate. It doesn't matter. Let's go ahead and choose the y's because that's what I felt like. So again, you ask yourself, well, what gets it so it eliminates? If I add them, it becomes 18, so I'm going to subtract it. So that means I subtract everything. Negative 8 minus negative 8 gives us 0. 2 minus 5 is equal to negative 3. This is when you ask yourself, is that true? Does 0 equal negative 3? All the variables have gone away. When the variables go away, this is when we have our special cases. When it's not true, that means it's no solution. If it was true, that's infinite. Think back to when we solved an equation just like this in our first unit. In conclusion, you eliminate the variable that has similar coefficients. Doesn't matter if one's positive, one negative, just that has the same number. Make sure you're adding or subtract to eliminate. And again, eliminate means to get rid of. You want to make that part to actually equal 0. And be sure to answer your survey questions that follow this video. Have a great day.